Good morning, everyone. Thank you very much for joining us today in this third webinar of the EOSC SIESTA webinar series. My name is Judith Sainz Pardo, and I will be chairing this webinar today. I'm a postdoctoral researcher in the Institute of Physics of Cantabria from the Spanish National Research Council. And today we have the pleasure of hearing my colleagues Andrés, Saul, and Mikulas that are quietly related to the EOSC SIESTA project and mainly to the infrastructure development of the computing platform. So in this webinar, we're going to review the computing infrastructure from three different perspectives. The first one, the provider's view, the second one, the user's perspective, and the third one, the developer's view. So at the end of each of these three talks, you are going to have time for asking your questions. And in order to do so, we have prepared this anonymous pool in which you can include your questions for each speaker. And then at the end of each talk, I will pass these questions to each speaker. So you can access to this pool using this QR code, or you can join slido.com and then enter these numbers. And also you have the link in the description of the video and also in the chat. So let's start with our first speaker. Today we will start with Andrés Heredia. Andrés is a researcher at the Spanish National Research Council, specifically at the Institute of Physics of Cantabria. His work is focused mainly in DevSecOps methodologies and the orchestration management tools. He's a PhD student with a focus in developing confidential computing platform, which is quite related with the Siesta project. And he has participated in several European initiatives, in several European projects, such as the Siesta 1, the A4EOS project, and also in the modernization of the Copernicus data store. So, Andrés, floor is yours.
Thank you so much. I'll share my screen now. Can you please confirm that you can see it?
Yeah, we can see it. Perfect.
All right. Great. So good morning. And thank you to everyone that is watching us either live or after the webinar is finished. Thank you, Judith, for the nice introduction. Again, my name is Andrés Heredia, and today we'll be talking about the Siesta platform from a platform provider point of view, the technological foundation and infrastructure that we're using. Let's go quickly over the agenda. First of all, who is this presentation intended for? We'll do a quick platform overview of what we have at Siesta. So then we can check the requirements that are needed to deploy a platform similar to the Siesta one. And then we have three demos today. The first one will be deploying virtual machines and configuring a Kubernetes cluster using some automation tools. Then we will be checking how to expose services in this newly created cluster. And we will configure also Argo CD that will enable us to deploy using a GitOps approach. And finally, we'll be reviewing a concrete example of how to use Argo CD by deploying the Siesta dashboard. Finally, a little recap after all these demos, so we can be sure that we understood what we just saw. And finally, what's next for you as a platform provider. So who is this presentation intended for? This session is created kind of in a tutorial way. So it's mostly aimed to platform providers, system administrators, and even though some familiarity with topics like infrastructure as code, configuration management, and GitOps is required, I think everyone could benefit from watching it, even if you are just curious on how a platform such as Siesta is deployed. So fair warning given, let's do a quick overview of the platform. This is the third webinar, so I will just go quickly over it. Let's remember that we have a hybrid Kubernetes cluster. That means that we have both VMs on OpenStack and as well as bare metal servers with AMD EPYC processors. But this is just the base of the platform. There are many components that are needed in order to make this platform secure and confidential, as you can see here on the diagram on the right. I divided this in different categories, so networking, storage, and we'll be seeing today how we are deploying all these components so we don't lose our mind by doing that. It's mainly deployed using KubeSpray, that is using underneath Terraform and Ansible to create the infrastructure and configuring it, and Argo CD that, as I mentioned before, will enable us to deploy applications and components using a GitOps approach. The requirements that you would need to deploy are pretty simple, but sometimes are hard to get. So for example, the first one is to have access to processors that are compatible with trusted execution environments, TEEs for short. This is our case. We have access to AMD EPYC processors of the third generation that have the extension called AMD SEV SNP that allow us to encrypt RAM memory on the fly. So we have the data that is in use encrypt. Of course, we're going to use a cloud provider, in this case, OpenStack, and this cloud provider also needs to be supporting these mentioned TEEs. This was our case as well. We had to upgrade our OpenStack cluster. We talked about it in previous webinars as well. We also need inside a project and the ability to create application credentials because we will be creating servers, networks, and other things inside OpenStack, and at least one public IP and several domains to expose the services because we need to access them from the internet, such as the Siesta dashboard. And of course, the biggest requirements of them all, time and patience. If you work in the field, you know what I'm talking about. Let's jump quickly into the demo because we don't have much time and they are quite long. For this demo, we'll be using the Siesta KubeSpray deployment. This repo is in here. You can access it, it's public. And actually, if you see here, there is a README that I will be following during the demo. So if you see me copy pasting comments there from here, you can go and check it. And in this demo, as I said, we will be creating the base infrastructure. So we will be creating some VMs and configure a Kubernetes cluster from scratch. Let's start with the demo. This is unfortunately a video and you'll see why, because it will take too much time to show it live. Let's start by cloning the mentioned repo. And one of the first things that we have to do is to create a Python virtual environment so we don't mess with our globally installed packages. This is the recommended way to do it, and it's a standard nowadays. So let's create this virtual environment and activate it so we can start installing our packages that are required to function. Inside the KubeSpray folder, there's a requirements.txt that you can use. KubeSpray is based on Ansible and Terraform, so it's using inventories to manage your clusters. Inside here, you see that there are several KubeSpray versions. Use always the latest one. The previous ones will be deleted, and they are there for historical reasons. And in here, you can see the packages that are being installed, such as Ansible cryptography, but we will be installing also the Python OpenStack client in case we need to debug something on the way. By the way, these videos will be uploaded afterwards, so you can go check them again and pause them if this is too quick for you. Next step is we'll be creating our inventory. Let's export this variable. We call it Siesta webinar inventory name, and we'll be using the Siesta EU prod folder to have a base for our new cluster. So let's create it, and we still need two extra files, one folder and one file that we have to copy from the KubeSpray folder. In this case are the config, the contrib folder, and the host file. And we can check that we already have them here. And as we see, they are just some links. This is all we need in order to start proceeding creating our infrastructure. So let's go into the cluster.tf bar file. And let's configure a cluster. Let's give it a name. Cluster name will be Siesta webinar in this case. And make sure to check all the fields here. This file is really important. So check things such as the public SSH key that will be used to enter the nodes, the image, this you have to have it in your OpenStack. If you want to use bastions or not, in this case, we have already one created, so we won't be using one. And let's define our master and worker nodes. To define them, I like to define them here in the KAS masters field. We will leave just one for demo purposes. Check the fields again, the flavor, this you find inside your OpenStack and it's dependent on your infrastructure. And define as well the worker nodes in the KAS nodes. We will leave just one again for demo purposes and check the rest of the fields that are dependent again on your OpenStack configuration. So for example, this one that we don't have at IFCA neutral routers, so we have to set to 0. After you spend some time configuring this file, this is the one that will take you most of the time. What we will do is to create an application credential. You see me here deleting the old one, so you can see that it's created a new. We'll call it Siesta webinar. I'm inside the Horizon dashboard, by the way, for OpenStack. And let's set the expiration date to yesterday, so I don't have trouble sharing the secret. Don't worry, it doesn't work. Let's download the RC file inside our webinar folder. And we see that we have it here. In this file, we need to add an extra variable that is required by KubeSpray, and it doesn't come by default. So let's add this export OS application name, and we'll be calling it Siesta webinar. Let's double check that it's the same name as our application credential. It is, so we can go ahead, save it, and then we can source this file. So we have these variables, environmental variables in our terminal. Once we do that, we can already check that using the OpenStack CLI that we don't have any Siesta webinar servers. So you know that what we're doing is true. We are not fooling you. We don't have any. So let's jump into the next step, that is executing make prepare. This will download and install Terraform and Kube Control. So there are tools that are needed. The first one to create infrastructure and the second one to interact with Kubernetes. And it will also create a copy of your Terraform state in a bucket in case you do have S3 in your OpenStack. So we have this created already, no errors. We can go into the next step. The next step will be to add the path of our inventory to our path, global path, so we can execute everything. Excuse me. And then we just go ahead and create our infrastructure by running make terraform all. As the name says, this will use Terraform in order to create, using these cluster.tf bars that we just configured, it will create a list of resources that will be added, changed, or deleted. So it's really important that you check what it will be doing. Ignore the warnings for now. The most important part is this. It's planning to add 23 things. There are many things that are added. The most important ones that we want to see are the instances, so the servers. It will be creating two, one called master one and another one called worker one. So if everything is correct, we checked again that nothing will be destroyed, really important. We type yes, and it will go ahead and create our infrastructure. This is not sped up, by the way. It takes little time, and it's creating directly inside OpenStack all the needed resources for the Kubernetes cluster that we will be configured afterwards. This still creating will take a couple of seconds more, but once it finishes, we will see that we have 23 resources added to it. And we can double check again using the OpenStack CLI that we do have indeed these servers created. So let's run again this command, OpenStack server list, and we see that we have both our nodes created that we just defined in the cluster.tfvars file. So once we have that, we can execute a bash script that we have for creating the security groups that are needed for the cluster. Before we start configuring the Kubernetes cluster, this will take a while. This is sped up, fair warning. Will take a while, and here you see that it's keeping all of them because they were already created. This is also great, so you won't break anything if you execute it again. We should see that everything is created successfully, so we can start creating and configuring our Kubernetes cluster. This is the next step. Let's run make kubespray all. In this case, kubespray will use Ansible instead of Terraform to connect to the nodes and start configuring it, downloading everything, certificates, and installing add-ons, etc. Add-ons such as the Cilium plugin, the Cinder CSI plugin to dynamically provision volumes, the Nginx controller, etc., etc. And at the end, it will give us a fully configured and production-ready cluster that we can start using right away. This, as you can see, is also sped up and is the reason why I cannot show you this live, because it takes around 15 minutes to run. It depends on how many nodes you have. The more nodes you have, it will take more time, not so much. So, but still, it's something to take into consideration. After it finishes, we see that we don't have any errors. If you find any error during the process, you can sometimes just try to run it again, and many times it would work because maybe there was a timeout. We see that it ran for almost 15 minutes, and the next step for this, if everything is okay, is to gather the Kubernetes configuration. So for that, we have another script. We can execute make Kubernetes config private. Private because this server is in a private network, so it's not. It doesn't have a public IP. As you can see here, it's giving an error because it's trying to connect to a public IP. So this is expected, but we do have a bastion host that we can use for that. As I mentioned at the beginning, we won't be creating a new one, but we can create an SSH tunnel using this command here. And using this tunnel, we can already run again this command, and this time it will be successful. It will gather the configuration from the master node, and it will test it. So everything is okay. Looks like we have our nodes, and it also gives us an export line that we can use to start right away using our Kubernetes cluster. Let's export this variable. So we can use kubecontrol get nodes, for example, and we see that we have connection and interaction with our Kubernetes cluster. So this is everything. We have already now created a Kubernetes cluster with 2 nodes, 1 master node and 1 worker node. This is the end of this demo. All right, but what about bare metal servers? We talked about bare metal servers, that we have a hybrid cluster. And for this, it's a little more cumbersome because the host file needs to be created manually unless you have a provider for bare metal servers. It is also possible sometimes in OpenStack, there are projects that allows you to manage bare metal servers from OpenStack. This is not our case, so we have to do it manually. You have examples inside the repository. So you see here, for example, is host example, and you have to set any bastion host that you have to use to jump. In this case, we do. And you configure here your bare metal nodes plus all the virtual machines that you have already. And the only thing that you have to keep in mind is that you don't use Terraform for them because they won't be managed by Terraform. They're bare metal servers. And to just use the kubespray all or kubespray deploy command it will do the same. So if you add these bare metal servers to your host file and you do run make kubespray all, this bare metal servers will be added to your cluster. Unfortunately, I cannot show it to you because we only have a few bare metal servers and they are delicate. And it's also a good idea to label and taint these bare metal servers so you can restrict the execution of things in this server. So for example, for us, it means that only confidential word logs will be executing in there. So you can use labels and taints for that. And we have a next demo. And in this case, we have already our Kubernetes cluster working. We'll be using the same repo as before. And let's go from the base that we had before. So in here we see, hopefully you can see it well. So we have our Kubernetes cluster. Let's test again that we do have it. So we have our master and worker nodes. And in this case, we'll be using a trick of the Ingress controller to expose our services. We'll be giving this worker node a public IP. And the workaround is that by default, kubespray, it's deploying the Ingress controller using a daemon set. That means that it will run in every node that we have in the cluster. In this case, we only have one, so we can take advantage of that. As we can see here, we are checking that it's actually true, it's using a daemon set, and is using a service type of load balancer that is not working because on our OpenStack, we don't have load balancers integrated. So one trick that we can do is if we can find the addons.yaml file that configures the Ingress Nginx, for example, we can set the host network to true and leave the load balancer as it is. And that means that the service, the pod that will be running the, excuse me, the Ingress controller will have the IP of the node itself instead of having an internal IP. Once we change this field, we have to run again, make kubespray all or kubespray deploy. Both of them are okay. They're doing mostly the same. And this also sped up because it takes a while. It can be done quicker if you know which tags to follow, but this is more advanced usage. So you can just run it if you have patience. It will do the same job. It won't break anything. If everything is okay, let's check again that nothing changed in the Ingress namespace. So everything looks the same, but we do have now the pods that have the IP of the node. So we can test this if this is true by accessing the IP, the public IP here. So, and here we can see that we have a 404 not found Nginx error. So that means that we are accessing the cluster already. So we are finally able to deploy things here. So if not, we would get the connection rejected. So let's go ahead and try to expose the Argo CD dashboard because we will be using that for deploying our applications. If we go to the utils Argo CD overlays folder, we can find one of the customization YAML, for example, for the IFCA side, then we can use for this demo. And we'll configure these. These are patches that are overriding some values. And we will be configuring here the domain that we created for this webinar for demo purposes. That is webinar-gitoff.cloud.eosk. It's needed a secret that will be created in the background because I cannot show you, of course. But if we apply this manually, these are only the few manual steps that we have to follow in order to have the platform running. So by using kubectl apply -k, and we point it to this folder, so overlays IFCA, we see that it will create, it will configure the config map, it will configure the roles that are needed, and it will be using the Siesta keycloak to be able to connect to that. So let's enter here. We see that we have an error. This is expected. We haven't configured anything for the certificates, but we still are able to enter and to see the Argo CD dashboard in the domain that we created before. But we cannot log in into keycloak just now because we are using HTTPS, but we have a problem with the TLS certificate. So inside the utils folder, we also have another folder called apps where we have a cluster issuer. And because KubeSpray is installing this by default, it's already configured, we can just apply this cluster issuer.yaml file. Please use your email so I don't receive the notifications for your domain. But if we apply this, it will automatically be using a Let's Encrypt certificate. Let's check that that's true. It's going to take a while, so maybe it's a problem with the cache. Let's open this in incognito mode, and we can see already that we have already our certificate. We have a certificate from Let's Encrypt is valid, so we can now log in using Keycloak, Siesta Keycloak. I will be using the IFCA single sign-on in this case. Let's fill this, and we are inside our Argo CD dashboard. And in here, we can go ahead and start creating applications. The idea would be to use a repository for this, but we can test it here. We have some demo Bootstrap app, for example. We're using the app of apps approach for this. So you can see here, we can copy this and create it manually. But this, it's pointing to the Siesta deployment, another repo that we have, and it's pointing to the Siesta cluster one. So this is the production cluster that we have. So all the applications inside it are configured for the Siesta cluster. Ideally, we would need to point to Siesta webinar cluster, but since we don't have it, and for demo purposes, we will just create this app of apps to Bootstrap our server, sorry. And let's see what it does. And as soon as we create it, we have many components being deployed already inside our cluster. This is fantastic. All of these components are in a repository, so they are versioned, and all the changes have to be done in the repo. And this is the conclusion of the second demo. Hope you liked it. And we saw already some challenges that arise, which we're just starting, and we already see that depending on your underlying infrastructure, there are many ways to expose your services. We are using here a workaround, but maybe it's not the best thing to do in production. It's not really recommended. For that, I would recommend using a proxy virtual machine to simulate load balancing, for example, or even better if you have OpenStack Octavia that allows native integration with Kubernetes. So if you create a service with type load balancer, it will just receive a public IP. We also saw that bare metal servers need to be handled carefully. You saw that there are many things that are being configured. And if something goes wrong, virtual machine, you can just recreate it. But the bare metal server, if something breaks, maybe you need to involve a different team for them to fix it if you remain without network, for example. We also saw the problem with the certificates, and I gave you an example on how to quickly and easily use Let's Encrypt certificates. KubeSpray is configured for that. In our case, we have this repo configured for that, but we're using our own, so that also depends on your infrastructure. And the bottom line is that there is no good for all recipe. I cannot give you one repository that will work for every kind of infrastructure, but at least it gives you a base so you can start deploying your own platform. Finally, there is this last demo. I think I'm running late, but I'm feeling brave. I'm gonna try to do it live, if that's okay. We'll be using another repo in this case, is the Siesta deployment repo. Let's go ahead and open that. And inside here, we have the different clusters. Let's clone this. Let's open here a Visual Studio Code. So you see here that I don't have anything, right? Let's create a new terminal. Let's clone the Siesta deployment one. And inside here, we have different clusters. Some of these clusters are more complex than others. So for example, we have the CNRS cluster that it has few apps that we can use this one as an example. So Control C, Control V, we can create a new cluster that is called Siesta Webinar. Let's call it Siesta Webinar 2 because we have here another one from a previous attempt. Inside here, we see that we have this app of apps that we created before. We saw in the demo that we created manually. It's pointing to CNRS cluster. We're going to change that in a moment. And we have 3 different apps. These 2 we don't need for now because we will deploy only the SIESTA dashboard for this demo. Inside this file, there are many comments saying that you have to substitute this with your domain. These 3 we can leave for now because we will be deploying later, so it's not important for now, but this we do need to change. So this is cloud, and this is webinar dashboard. Let's go ahead and accept this, and we'll do the same for the rest of the fields. Okay, it's quite intelligent. It's catching this that we need to change. So a total of 5 fields that we configured. Let's save this. Let's change the namespace where we want to deploy. So it could be Onyxia webinar. And let's change the application name, Onyxia webinar. It's good. I think everything is all right. So we have our app of apps. Let's copy and paste this. This is the only manual thing that we have to do. We're inside our webinar GitOps. Oops, unfortunately, I have to log in again. Sorry about that. This is the demo effect. I'm inside here. Let's create a new app, edit this YAML, and let's point this to cluster Siesta Webinar 2 apps. Add the same repo, Siesta deployment. Let's save this and let's create it. It will give us an error. This is expected because it's trying to check a path that does not exist. So that means that we need to actually add this new cluster, Siesta Webinar 2. So let's go ahead and do that. Let's jump into Siesta deployment. Git add clusters. A simple commit will suffice. Add Siesta Webinar 2 cluster. And once we push this, we should be able to create this again. I forgot to change this, but it's not a problem because this will be creating it manually. So this is the important file. Let's try again and create this. And right away, we see that it's creating our Onyxia webinar application. We didn't have to specify this. This is uploaded to our repo. And this will take a little while to create. It's creating a pod. Onyxia webinar API is taking a while. And this it's containers running, started and ready. That means that we should be able to access now the dashboard that we just created. And we see we have the same problem with the certificates because we didn't configure that yet, but here we have it. Thankfully, everything worked. And you have the Siesta dashboard up and running. This concludes the final demo. So you saw how to, using a GitOps approach, you can deploy the Siesta dashboard. You also have here the video on YouTube doing the same, so you can check it afterwards. And finally, after all these long videos and demo, let's do a little recap. We saw again a quick overview of the platform, what we have at Siesta. We deployed some base infrastructure using kubespray, so the VMs, and then we configure the Kubernetes cluster using Ansible. For that, we saw that we have a makefile that allow us to quickly do that. We checked how to expose services to the internet using ingress controller workaround, and also talk about other options. We configured Argo CD so we can expose and use keycloak to enter the Argo CD dashboard. And finally, we used Argo CD to deploy the Siesta dashboard using a GitOps approach. So what's next for you? And finally, we're finishing now. As a platform provider, as a system administrator, so you have to finish configuring all the apps. Note that not all of them are needed. You can check the Siesta deployment repo, and you see we have all the clusters. For example, the Siesta cluster is the one that we're using in production. There are many applications that are being deployed. But for example, if you do have a Keycloak instance that is running outside, you don't have to create this one. So please go and check which applications you need and create them one by one. The same as we did with with the Siesta dashboard. And the next step is to finish configuring the Siesta dashboard. As I said in the demo, there were some things that we didn't change because you need to also have a MinIO and Vault services for that. And for this, I encourage you to stay for the next session given by Saul. Really nice session. Well, he will go through how the Siesta dashboard works. And finally, if you stay for the latest session given by Nicolas, you'll see how to security harden your cluster. So I also encourage you to stay for that. And finally, once you have your Siesta platform up and running, please feel welcome to contribute to the Siesta project. Everything that we're doing is free and is public. We're using our GitLab. So here you have the URL, and feel free to open us a PR if you want to contribute. That's everything from my side. I hope I didn't take much of your time and you find this insightful. Here's my email, and if you have any questions, you can reach out to me and I will answer to you as soon as possible. Thank you.
Thank you very much, Andres. Thank you very much for all the demos, but mainly for the interactive one, because it has been very interesting to see it live. So let me put here in the slides the link to the pool so you can ask your questions. But in the meantime, we already have two questions, so let me check. The first one that arises at the beginning of your talk, Andres, says that if we can use, if virtual machines must be on OpenStack or if other cloud providers, often proprietary solutions, are also supported.
They are supported. It doesn't have to be on OpenStack. We use OpenStack, so therefore we're using it for our demo, but there are many providers that support it. I would say go to the kubespray documentation and check all the providers. Proprietary ones are also supported, such as AWS and Google Cloud. So there's no problem with that. You might need to adapt a little bit the TF state depending on which variables are expected. So you can expect the demo that you saw to work right away on an OpenStack cluster, but it is also possible to use other cloud providers.
Okay, then the second question that we have, it's about the time that you mentioned at the beginning of your talk, because it says that how long does it take a research group with the appropriate resources to set up its own instance of the infrastructure?
Right. As we said, there are many variables that come into account. So it depends on the infrastructure, because there is no a recipe, a good for a recipe. As I said, it will take a while. Here in the demo, we saw that it takes 50 minutes to create the base infrastructure, a couple of VMs, etc. This is if you don't have any errors, if you don't have any special requirements, if you don't require manual steps. But I would say it shouldn't take much because most of the steps are automated. So given that you have the appropriate knowledge in system administration in Kubernetes, etc., I would say a couple of days, you could have a basic infrastructure, a basic platform up and running. And from there, you can start building in top of it.
Okay, and our last question is how many clusters are supported until now? I assume that in the Siesta, let's say, cluster. You have mentioned only the CNRS.
Yes, so this is because we're still consolidating the work between all the three sites. So three sites are supported, or they're thought to be supported in the future. Right now, everything that we consider production is running at IFCA. So it's just one cluster, but the rest, the other two are almost there. We are just polishing in some touches so they can start receiving worklogs there too. So I think answer to your question is 3, but at the moment it's just one. But the other two are coming really soon.
Okay, so thank you very much again, Andres, for your talk and for your time. So now we can move to our second speaker of the day. Now we are going to move to the second part and we are going to focus on the user's perspective. And for that, we have here Saul Fernandez, which is a colleague also from the Institute of Physics of Cantabria, from the Advanced Computing and E-Science Group, affiliated also with the Spanish National Research Council. And his work focuses mainly on the development of infrastructure solutions for orchestrated execution of workloads and the development of scientific computing infrastructure. He has also taken part in several European projects, such as, again, the EOSC project, but also the A4EOS1 and the iMagine project. So, Saul, thank you very much again, and the floor is yours. We can see your slides, but yeah, you're
Okay.
muted.
I think that now you can hear me. Thank you,
Yeah.
Judith, for the introduction. Well, so let's start. Well, in this presentation, we're gonna take a look at the different components and services that make up the platform and that users directly interact with, as they can be like the user interface, as Andres has mentioned, it's based on Onyxia, but we also review the platform storage based on MinIO and the secret storage based on Vault. During the presentation, we will take a look at different deployment scenarios or to different demonstrations about how to interact with the platform, how to deploy services, and so on. Then, from a platform operator perspective, we will take a look at the different component configuration, the main files, their location, what to change. We will see how we can define a catalog and how to manage a catalog of services, that the services that are going to be listed on the platform. We will review some non-out-of-the-box integration we've developed within the context of this SIESTA project, and we will discuss about the current work in progress. So, what do I mean by platform? In the context of this presentation, we will refer to a platform as the set of components that allow a user to deploy a service on the project's computing resources. The platform is accessible through this link that points to the dashboard, the initial dashboard of the Siesta project. And once we access this dashboard, we will get in something like that, this project dashboard homepage. From here, we can, for example, click on the left side on this service catalog section. And if we do so, a list of services will be shown, showing all the services that are available in the platform for the deployment. We can read the descriptions, choose a service. In this case, let's say we want to deploy Jupyter Python, and we will get into a configuration view. From this view, we can specify different configuration parameters to deploy the service inside the platform, like, for example, the environment variables, the Vault configuration, the storage configuration, and so on. So once the configuration is ready, we can hit on the launch button and the service will start running inside the platform. We can then click on the left side again on the My Service tab to access all the running services that we have deployed inside the platform to review its name, its status. We can delete the service, access the exposed ports or the exposed services, etc. So this is like a general overview from the user perspective of how to deploy a simple service. Let's take a look at the subjacent infrastructure that supports this scenario. Here we have a user, and the user is mainly interacting with the SIESTA dashboard, as we have seen, and this dashboard is being authenticated using a keycloak instance. Once the user is authenticated, he can use the SIESTA API through the dashboard to first retrieve, as we have seen, the list of all the available services. All the services are defined on a GitLab catalogs, so the SIESTA API is retrieving this service information, showing or exposing it to the user, and managing the life cycle of the service the user wants to deploy. Also, this SIESTA API is connected with a Vault instance for secret management and to a MinIO instance for storage management in a way in which users can interact with Vault and MinIO from inside the platform and also access the resources on the deployed services. So let's take a deeper look to the Onyxia or SIESTA dashboard and API. And first, let's talk about what is Onyxia. Well, Onyxia is basically a graphical interface for deploying Helm services. And what are the Helm services? Well, Helm is the Kubernetes package manager used to define, configure, and deploy applications through reusable charts. This means that the service is defined as a set of templates that are going to be completed using specific values for each specific instance of the deployed service. Onyxia is a graphical interface for doing that, but also it adds authentication because it's connected with the keycloak. It manages the service catalogs visibility. Catalog services are grouped into catalogs, and Onyxia is managing that organization and also allow users to manage the storage and secrets from inside the platform. As we have seen, it's composed of two main components, which are the Onyxia dashboard and Onyxia API. And as we have seen, the API reads the service catalogs that are hosted on GitLab, expose that catalogs, that services to the users, and manage the deployment lifecycle inside the Kubernetes cluster. So in this way, users can browse, configure, deploy, and manage services without interacting directly with Helm or Kubernetes. So Andres has made a kind of introduction to this topic. Let's talk about now over the Onyxia deployment. And as you can see, Onyxia is itself defined as a Helm chart, as a Helm service. The Helm chart that specifies that service is hosted on our GitLab, on our hardware repository, and the values file that configures that instance is hosted on the GitLab. In this way, with these two main components, Argo CD is able to manage the life cycle of the service inside the Kubernetes cluster. So now let's take a look to this Onyxia values file, which is the values file that is configuring the Onyxia deployment inside the SIESTA platform. On top of the configuration, we have, for example, this ingress part in which the domain is being set. We also have this secret part in which the Kubernetes secret that contains the certificates needed for encrypting the site are defined. Then we have a web section. In this section, basically there are defined all the graphical aspects of the dashboard or the SIESTA dashboard, as there are the icons, the logos, the fonts, the colors, etc. And then if we go down, we have this API section. In this section, first, there is defined the keycloak authentication, the keycloak interconnection of the Onyxia service with the deployed keycloak instance. Then in this regions part, we have basically the MinIO and Vault interconnection. We are pointing here to the MinIO instance and to the Vault instance. And lastly, we have this catalog section inside the Onyxia configuration that lists or that contains all the configured catalogs. Each catalog is a GitLab repository, and in this section we are pointing to each of these catalogs. But let's take a deeper look to this catalog definition in the presentation. Let's talk about this SIESTA catalog or service catalog definition. So, how services are defined? Well, services are defined as a Helm chart, as I have already mentioned, and in order to define these services, a developer have to upload the chart code into a Siesta catalog inside a GitLab repository, the Siesta GitLab repository. Once the developer uploads the code, a couple of pipelines inside the repository starts running, and as a result, a release file is created. The release contains the build of the chart and is stored under the releases section in the GitLab repository. Once the release is ready, another pipeline will update and upload an index.yaml file to the GitLab pages of the project. This index file is accessible from the outside because it's published on the GitLab pages and basically contains the list of all the services that are defined within the catalog. It contains the description of the services, their versions, their dependencies, and for each service contains a pointer to the release file that has been uploaded earlier. So we can take a look to an example of an index.yaml file of a production catalog we have developed. And as we can see, we have different services defined, in this case, a client for federated learning, Guacamole, Jupyter Python. There are several services. For each service, we have their dependencies, their description, some keywords, and lastly, the pointer to the release, the concrete release of this service. So, once we have seen that, let's talk about how it's structured in the inside a Helm catalog. Well, this is a diagram of the directories that are found in a GitLab repository that hosts a catalog. We have the catalog itself in the top part of the directory tree. And then we have two folders, the charts folder that contains the service definition and the scripts folder that contains the scripts needed for running those pipelines that will build the chart, publish the release, update the index file, etc. So if we take a closer look to a service and the contents of a service directory, we see that we have a template directory that contains itself the full Kubernetes definition of the service. We have here defined the stateful sets, the PVCs, the ingress, the secrets, all is defined in a form of a template inside this templates folder. Then we have the chart.yaml file that contains basically the name of the service, the version, the dependencies, the description, etc. And then the values.yaml file that contains the default values that are going to be used when deploying this concrete service. These values are going to be used to render those templates and to conform the final Kubernetes service. Lastly, we can see a values.schema.json file that is not part of the standard Helm catalog structure. This file is needed by Onyxia in order to render the configuration fields shown in the dashboard, in order to know which fields fields of the service needs to be configured in order to deploy the service. So let's now check how to create a service catalog in a GitLab repository. Those are the steps. We first need to create a GitLab repository. It needs to be a public repository, and we have to ensure that the GitLab pages are publicly accessible from the outside. This is an option that is not enabled by default, at least on the Siesta GitLab and the Siesta's GitLab. Then we will have to generate a token for him to publish the charts once built. We need to save that token as a repository variable for the continuous integration process. And then we were ready to upload the pipelines, create a GitHub pages branch, which is necessary, then upload the first chart, the pipelines will start running, the service will publish, and we can add that service catalog to the Onyxia configuration. So let's go part by part. In this part, we are creating an empty project, a public project, and we are ensuring that this page section is publicly accessible from outside to any user. Then we are generating a Helm token for the build and release processes. We have to ensure that the role contains the necessary rights for the publish process. And then we are going to save that token as a continuous integration variable inside the repository. So with that done, we can upload the different scripts for the pipelines to build the Helm catalog. We can upload an example chart, and we have to make sure that this GitHub page is already present on the repository. With that done, is the moment of modifying the Onyxia values file in order to add a new catalog, as I've mentioned earlier, and this catalog will be pointing to the new GitLab page of the repository we have just created. With that done, here we can see that the Onyxia interface, now the testing catalog is listed, the catalog we have just defined. So now that we know how can we create the catalogs, let's talk about how can we restrict these services. So services, as we have seen, are organized into different catalogs according to their purpose or target users. Each user can only access a restricted set of catalogs, or only will need to access to a certain type of services. So the catalog visibility can be controlled through Onyxia using the Keycloaks roles or Keycloaks group membership. This is done because after authentication, Onyxia determines which catalogs the user is authorized to access, and the dashboard will only display the catalogs included for that users. In this part of the Onyxia dashboard, we have the different catalogs that are being listed. We have an anonymization catalog, a general text catalog, an IPDMLG catalog. And the visibility of those catalogs are going to be controlled with the restrictions that are defined on the Onyxia definition file we have just seen on the catalog section. In this case, we are limiting a catalog to be just shown to the users that are part of the use case one group on the Keycloak instance. So now let's talk about that Keycloak configuration. Keycloak, well, is basically the identity provider that we are using the platform. And in this Keycloak, users will be organized in different groups and assign roles according to their access requirements. This will help Onyxia to determine which catalogs are gonna be shown to each user. This Keycloak is not just used by Onyxia, it's used by a lot of services. And in the case of this presentation, in the context of this presentation, Keycloak is also being used by the S3 object storage, the MinIO instance, and also the Vault Secrets Manager. So about the Keycloak, we are also working on a RDCM integration. What's this? Well, this is basically a plugin that we are working on the integration. And this plugin, the idea is to extend the Keycloak functionality with self-service group membership capabilities. This means that for each Keycloak group, we will have the ability to designate some group administrators in a way in which users that want to join to a group can make a request for joining that group, and the group administrator will have the rights for reviewing that request, accepting or denying it. The idea with that is to delegate the access management without requiring platform administrators to manually handle every user assignment. The integration with this plugin is not fully completed. We are currently working in progress to integrate this plugin. Here you have the official repository of the Keycloak group management plugin we are talking about. Now let's go with MinIO. MinIO is, as you may imagine, the personal user storage service that we are using inside the platform. MinIO, as well as the Onyxia dashboard, is deployed as a platform service in the Kubernetes infrastructure. It's deployed in a form of a Helm chart that is being managed by Argo CD as well as Onyxia, and as well as other services that are being managed by Argo CD in this way. Onyxia has configured Onyxia has configured this Minayo instance as the default remote storage solution, although there is the possibility of adding more remote storage providers. And what's doing Onyxia with that is adding or injecting the Minayo credentials inside the user containers that has this option enabled, but it's not managing the access itself to the storage. It's just injecting the required S3 credentials and configurations in the form of environment variables. So over that, we have extended the functionality by adding a sidecar container to some services. This sidecar container, the idea is that mounts the S3 bucket of the user in the form of a shared volume. This volume is then shared with the main application container, making the S3 data available through a standard file system path. Let's review this Minayo deployment. This is hosted on the Argo CD project in the SIESTA GitLab, and here we have the definition of the Minayo service. Just to highlight, for example, the ingress definition in which we are setting up the domains and secrets that are going to be used to expose that Minayo service. We can check also the OIDC configuration. That's basically configuring the keycloak and Minayo so users can authenticate in Minayo using the project keycloak, and so on. So going back to the presentation, let's talk about more non-out-of-the-box features that we have developed within the context of Minayo inside the Siesta platform. With Minayo, we have been working on a shared S3 bucket that can share among different users. The idea is that the users can share the credential for accessing a shared bucket, and that bucket will be mounted inside the running service as well as the personal bucket. We have also developed a functionality in which a dataset can be directly downloaded into a user's S3 bucket during the service deployment. This is an example of the configuration of these two functionalities. In the upper part, we have this dataset functionality. We see that we can specify the DOI of a service, the DOI of a dataset, and this dataset will be downloaded into the personal S3 storage of the user during the service startup. In the lower part, we have the shared S3 configuration in which a user can add the credentials for mounting an external bucket that is shared by another user. So there are three different ways of interacting with Minayo. The first one is using the Siesta dashboard that we will see later. Then we have this Minayo console that's deployed as a platform service. In this Minayo console, we can authenticate using the project's keycloak, and once authenticated, we can access and manage the user personal storage. In this case, we're going to access my personal bucket where I have uploaded a couple of files. Then we have another option that is use any S3 compatible client. The instructions and credentials for using those clients are available on the Siesta dashboard under the account section of the profile, of the user's profile. Lastly, let's talk about the Vault. Vault is the service that we are using for managing the secrets inside the platform. It's not fully deployed. We are still working on it, but what are already ready is the integration with Onyxia, in which users can define their own secrets in the platform, and that secrets can be accessed from inside the running services in the platform. So a user can define a couple of secrets and can configure the services to access those secrets in runtime. For example, in this screenshot, we have defined a password secret, and then in the service configuration part, under the Vault section, we can configure that secret to be mounted inside the running container as environmental variables. We are working on some non-out-of-the-box features of Vault, like secret sharing. The idea of these features is that a Keycloak group administrator will have the rights to share some secrets with the users of that group. He can choose to share the secret with the whole group of the whole Keycloak group, or with just specific members of that group. And there are two ways of sharing the secret. The first one is a non-restricted way of sharing the secret, in which users can access the secret from outside the platform, and also from inside the platform through the Onyxia services that are running. There is another option of sharing secret, that is the restricted one, in which users are not allowed to access the secrets from outside the platform, but they can use that secrets on the services they are deploying inside the platform. So the secrets are not accessible from the outside, but are accessible from the inside in the form of configuration for the services. This is not in production yet because this functionality depends of the integration with the group management plugin of Keycloak. I've been talking earlier, sorry. So now to finish this presentation, let's take a look to a demonstration, a recorded demonstration, or how to deploy a service inside the platform using these functionalities, this secret functionality and this storage functionality. Those are the catalogs that are already in production, and we can see that under My Service tab, there are no running services yet. So let's start by creating a new secret. Let's call it test secret, and let's define two variables inside it. Let's call them var1 and var2 with the value test secret. The idea is to inject those variables in the form of environment variables inside the running service. Then let's check the File Explorer tab from which we can interact with the MinIO personal bucket. In this case, I have no files inside my bucket, so let's drag and drop one file. We can check that it's already uploaded by, for example, accessing the MinIO console and checking that the file has been uploaded. This is not necessary, just to show that the MinIO storage can be accessed, can be managed also from inside the platform or from this specific MinIO console. So once this is done, let's configure an example service to show this functionality. Here we are configuring the vault secret. We have called it test secret, and we are making sure that the S3 configuration is enabled. With this done, we are ready to deploy the service. We can click on the launch button and the service will start deploying inside the platform. Now the Kubernetes is reading the Helm chart, rendering the chart with the values defined, is allocating the resources, downloading the Docker images, and starting the containers. This process is not long. It shouldn't take a long time. In a couple of seconds, the service starts running and is ready for accessing the Jupyter environment. Let's wait. Okay, the service is now ready. Let's copy the Jupyter password, open the service, paste the password we have just copied, and access the Jupyter environment. From this environment, for example, let's open a terminal and check first that we have this remote bucket mounted in our field system in order to access the files from the standard Linux path. We can see that this test file is under the path S3 and my user ID, my personal user bucket that has been properly mounted on the service. And let's also check that the environment variables with the secrets have been correctly exported. So let's check it with this command for reviewing the secrets, and there are both secrets we have created, the var1 and var2 with the test secret value. So I think that's all for today. I hope you have enjoyed the presentation. Thank you very much for your attention, and I think that we are ready for answering any possible question that may have arisen.
Thank you very much, Saul. Indeed, we have already 3 questions. Let me share my screen just in order to show to the audience the presentation in which they can access the code for going to the questions and the system. So the first one that arises, I think that in the middle of your presentation, is if there are any plans to support OCD-based repositories in the dashboard. I see that it's using the old index YAML method.
Yeah, it's not really on our side. It's more a Onyxia limitation. We are in the project context supporting this kind of repositories. And proof of that is that the Onyxia service that is being deployed through Argo CD is being hosted inside the Siesta Harbor repository in the form of an OCI image. But it is not in our site. It's we are using the old index.yaml method because it's the requirement of the Onyxia platform.
Okay, so the second question that arises is what kind of tools can be used in the dashboard, as you mentioned different catalogs?
Well, in the dashboard, we are listing different catalogs. We have a general tool catalog that presents tools like, for example, a Jupyter environment, a Guacamole service, and this kind of more general services. We also have some anonymization services, like Anjana or TrustGDP or this kind of services. But mostly each catalog is relative to a use case. Each one of the use cases are creating some services for running inside the platform, and those services are grouped inside catalogs. So just the users of those use cases are able to access those catalogs.
Okay, and the last question, I think that I can address it because says that how can I access the Siesta platform? So until now, if you want to access the platform, you can contact the team, for example, via the web. You have the option of contact us, and then you send us your name, email, and why do you want to use the platform, and then we will get in touch with you in order to provide you with a test account and with a test password so you can access. Anyway, Saul already commented that it's work in progress to also integrate the EduGain credentials so that each user can access using its institutional credentials for joining the platform, and then the administrators could have the possibility of adding different levels of access permissions to the different tools. But as that is now work in progress, then the idea is that you can contact us, and then we can get in touch to provide you with the access to the different tools that you may need. And I think that's all. Thank you very much, Saul, for your time and also for your presentation and for your demos. And let's go to our third speaker. And in this case, we are going to go to the security hardening part of the platform. And for that, we have here today Mikulas Strelki, who is a senior cloud consultant in Interway, which is a partner in the Siesta consortium. Mikulas is a technical specialist, cloud practitioner, and he's provided technical guidance on the design of cloud solutions, governance, performance, scalability, security, and so on. He works with different solutions going from OpenStack, Cloud, Docker, Harbor, Kubernetes, and security hardening, Argo, etc. And he has also been involved in several projects, supporting mainly organizations in order to achieve their business objectives, to decrease the cost, and also to simplify in IT while moving to the cloud ecosystem. So thank you very much, Mikulas, for participating in this webinar, and floor is yours for this last talk.
Okay, thank you very much. Welcome if you join online before lunch. Of course, this is my last contribution here, or if you are listening or watching afterwards from the records. Our contribution for today is focusing on development and, let's say, integration view, how we contributed into the overall platform, which you have seen from Andres or Saul, how we contributed from the security hardening, and how we also support developers in this growing adoption of cloud-native technologies, distributing environments, which introduce more challenging in cybersecurity and compliance. So let's dig into this details. So we will focus a little bit more on secure CI/CD pipelines, how we can create more secure artifacts, how we can use it in the overall Siesta environments. What is inside regarding configuration, validation using tool like conftest. Then we also contributed with some additional tooling and involving like code quality and vulnerability analysis based on Sonar, and then securing the artifact management, downloading from the internet via Nexus repository. Much important part of this contribution is also following the container image signing, because in Siesta we also want to have secure images which are signed and which has, let's say, build of material, software build of material available to it, which also brings some information additionally about the security vulnerabilities and so on. So then we introduce some specific pipeline and catalog components from GitLab, which helps to create this image signing. This is the development part, but of course we are focusing somehow also on the runtime, on the platform part, introducing some security gates with OPA gatekeeper, enforcing some policies that only certain or defined storage or image store like Harbor is allowed to provide images for the overall platforms. So, and in the end, I will also touch some practical lessons which I see from the use cases which are onboarding on the platform and using this, let's say, tooling and these small pieces which we are contributing during, let's say, we call it VP12, which is work package 12, focusing on the security. If security hardening, if we divide it into three parts, we see that there is this security DevOps catalog available from with different components, which I will touch briefly shortly. Then also this is the platform runtime environment, which secures the platform overall via KubeSpray, which you have seen from Andres, and contributing with some tooling or policies which provides the Cilium cloud native networking interface, which is now part of this overall Siesta platform deployment. There is also some tool which I will introduce later on, which brings some total view of the overall platform, like from the security perspective, from the monitoring and runtime, and also from the traffic, which helps, which is running inside. This is the Hubble tool, Hubble viewer on this. We introduce also monitoring for Grafana with Grafana and Prometheus on top of the platform, that we can see everything together. And it's also tied together with one tool which is called Backbone Viewer. Let's see what we have here in NevSecOps platform. You have seen many times already in previous parts that GitLab from IFCA colleagues is as a one source of truth, where we've seen, or when we created several projects. One project is the last one is the catalog, which introduced different catalog components. So so the components are available here in this link provided for the overall view for you. So the components are here. If you go into the catalog, you may see this is the catalog, which has the different components and the variables available to it. The components are defined with the, let's say, default definitions. Of course, you may read more about the components here in the README and overview. Then of course there is a simple pipeline available for your educational and testing purposes, which brings you some additional value how to use overall components. Each component is independently includable, and composable, so you can use it together depending on your pipeline needs, because I don't want, or we don't want to push, let's say, certain habits to your development needs. But of course, experiencing the interactions with the use cases, we see that the developers or the use case members and teams have accommodated this approach, and they are following the approaches which we set in the security and hardening from the DevOps perspective. What is important, of course, that there is a general pattern for including any component which you need to follow, and then, of course, you need to check that there is a component which defaults to, let's say, right now, to the testing cluster. Beside that production cluster or demo cluster which Andres has introduced, we have a cluster for testing purposes, and there is a KH Siesta tag. So you need to remember, once you are deploying and composing your images or your artifacts, to use proper tag and proper runner for this tag, or with this tag, which is running on a proper cluster environment right now in prod or test. So, and then there is one last information which you need to follow, is that it's strongly recommended to pin components to specific tags. So, because in main we do some introduction or testing, etc. So you need to use some specific tag for some reasons to use this in your pipeline. So there is some more details about this. So the catalog is available on the IFCA environment, and there is some sample end-to-end pipeline which has different stages: build, scan, verify, etc. for and deploy. So we follow whole let's say, life cycle of the building, creating, developing, and signing the image from the security perspective, and also deploying on the platform, because it's important to have on the platform only secure images or only secure asset, which we know the source from which those images are coming. So this is very important for us. So what is the process overall to sign images? It's simply committing and doing some merge request in the GitLab pipeline. You have seen in Saul presentation, there is also some secure store with the Vault. Of course, you can integrate your pipeline with secure Vault store environment, or you can use the keys for designing images inside your pipeline, inside your environment variables. So this is what the other colleagues from use cases did. And then the GitLab is doing the magic behind with the pipeline. So builds the OCI image, sign. What we are using here, as you may see, we are using the tool called Cosign from SigStore. We are signing these images with the keys, and the image is signed and placed into the Harbor registry. We use Harbor because it's OCI compliant, has a cosign available, so we'll not allow to pull images to the cluster which are not signed, and then generate SBOM, which I said, check the security constraints or security violations or CVEs on a daily basis, or even more frequently. We can set up this and then notify the team which appropriate action you need to take to fix some security issues. So Harbor is integrated and serves as a one source of truth for us in a Siesta platform environment. Then, of course, you need to verify. So you can use a public key and verify the image, or verify the signature, and then be sure that you are deploying only signed image which is secure on the platform. So there is a pipeline, and if the time will permit, I will go through this in short demo, but you can see it in the GitLab on this link, that there is several checks or control gates for checking the environment or deployment files or YAML files with the conf test tool, whether it's aligned with some quality and security setups. So this is the conf.ts for Docker file, for example, at this moment. Then we shifted left the static analysis with the Sonar cubes. The Sonar is available also in from the security perspective on the platform as well. Building, signing the image, verification, and deployment. Then what is this image deployed? What you can see here is actually the screenshot from the harbor, where is the project called, for example, VP12 security. And in this project, I may have it here. Sorry. So as you may see, live here we have this let's say project available, and of course it's connected to the key clock, which you have heard about it already. And we have Hello project, which was let's say built yesterday, and the details about the image, that there is a SHA which is generated firstly when you deploy the image to the harbor, and then cosigning is using that SHA to create the cosign signature. And of course there is a tag specific for this image. So, and then of course there is ISBOM details for the image, so you can see the architecture of how the image was built, and what the packages are used in the current versions, and licenses which are alongside the components which you are using. So this is also very important. How we do this security, or we harden it? Of course, this is through the configuration, where the cosign deployment security is enabled and only allows the verified images to be deployed. This is one. Then, of course, automatically all images are scanned when you push the image to the harbor, and of course there is automatically generated SBOM on push. So this is prepared for everything, or for the deployment of images which are coming from the pipeline, or while using the catalog. Of course, there are different views. As you see, I am authenticated as a user, and I see only parts. I will take the opportunity to tell you that we created, or there is created also the project called Mirror, where I use also the opportunity to follow Saul information about the MinIO. Many projects are using rclone as a library, so rclone 166, and we discovered that also this rclone has some critical issues, and we also provide this 1742 version of the library, which has no vulnerability currently. So we recommend to review your deployments, not to download the image from the internet, but use Harbor as one source of truth, and deploy your connectivity from your application or from your user namespace to MinIO through this newest library. Download it from Harbor Cloud EOSC SIESTA.eu. So this is very important thing. So, I forgot one thing also to add, that beside the mirror, and we will place required libraries or required images here, that we have all the images available for your projects, at least, or you can use something which is called Docker Hub proxy, which I do not see it from here, from my perspective, but this proxy is available also to limit the Docker Hub downloads, and also serve as a cache for your images if you need something from your different environments. So saying back again, we need Harbor as a one source of truth for everything which is deployed on the cluster. I will tell you more about this later on as we come to the runtime security hardening. Now we have the projects and all this information which I touched. There are additional 2 steps which you might include into the pipeline. There is a Sonar, which you can use, and of course you need the credentials. We will help you with these credentials. At one time point, we will also add some connectivity to the key cloak. Right now, we are creating the users locally, and the project is controlled here. Some colleagues are also using, or at least in UC3, this Nexus repository as a cached mirror for Python packages. And then we are coming to the deployment. Of course, you are deploying the images which you previously built, secure, sign, store into the harbor as a one source of serving images for the projects. And then we have Cilium for the networking. Cilium networking policy is one our guard which serves inside the platform. And there is also OPA Gatekeeper. So there is additional tool which prevents you to deploy into the namespaces from different registries than harbor Siesta, for example. So we are controlling the one source of truth on the runtime environment. So we deploy the harbor gatekeeper and we set certain constraints. One is right now running on the platform and it's in power. Second is also focusing on securing your access from the user namespace to the MinIO bucket that you will use only specific storage class, which allows you to bind PVC into your namespace. I will tell you a little bit more shortly. So hardening the cluster runtime environment, Cilium CNI. Then second two, you have seen many times in the previous presentation that there is a Nginx ingress. Of course, you might know the story that there is some new way to approach the ingresses and expose the services from the cluster. Therefore, on the production cluster, we are running in parallel traffic, which follows all security fixes and also allows you not only to use ingress approach, but also gateway API. So this is additional hardening and help. But of course, we discovered that currently a lot of applications are using Nginx ingress. So we recommend also gradually to upgrade to traffic and separate the role for the platform team and for the development team, etc. Then, of course, Cilium with the Hubble as an observability component, which I mentioned already. Traffic plus LMA, I will shortly show you Grafana Prometheus, which we have here. And OPA Gatekeeper, which is the open source, let's say, policy engine. That's one thing, which allows us to define, manage, and enforce policy constraints on the production cluster. And Gatekeeper, which serves as an admission controller. And of course, there is some development on the Kubernetes groups and also in OPA with admission controllers, etc. So for these purposes, we are managing this through the pipelines deployment to keep the version and to keep the policies and constraints in sync. Because the development is quick, and to put it into Argo CD, as you have seen, may cause us some issues. So therefore, we created a policy, and we also apply these through the pipelines. We use GitHub as well. And this Gatekeeper policy library help us also to follow some patterns which aligns with the widely recognized frameworks which we follow, like NIST, ENISA, and some Kubernetes benchmark, etc., from the security perspective. And we are ready to apply more and secure more. But of course, you understand that if we are in, let's say, building and finalizing phase, we need somehow to do some compromises, whether the application will still run or will not run, because we are super secure. So we are waging this, and therefore we have like two constraints right now applied to the platform. So the deployment templates and constraints follows the pipelines available through the GitLab as well. If you are interested, there is a K8 allows repos. So right now we can see that there we have like 33 violation already, mainly because of the air clone, which is used in the user namespaces. The image air clone is download it from the internet. As I said previously, there is a newest version on Harbor already, so we can help you to fix the issue and provide the appropriate appropriate steps. What you can see also, there are other constraints available, or at least prepare for to take the enforcement, but of course we need to do it, let's say, in weighted decisions. Additional scope storage class. This is the use case which we discuss also in VP12 and VP9 platform discussion, how to secure users to accessing the storage. We apply this, let's say, user namespace scope storage class, which has some also several violations right now, because we have only one storage class called CSI Cinder, and this CSI Cinder is not the proper one which we expected, and we try to follow the pattern. If the user namespace has a user minus the ID from the key clock, we will follow the same pattern with the storage class. Yeah, so we apply this also on the test, on the prod environment, and if there will be more clusters in the future, we can also apply there. Final part, focus on the backbone viewer, which is available right now from the testing environment, but also helps you to sign with the proper rights and see what you need. Either you need to see the policy, to policy, like a policy manager from the OPA gatekeeper, monitoring, alerting from the some production on a runtime view, all to see the flow, how your application behaves, what are the connectivity between pods and services, on which layer, what kind of security gardening or security hardening or security gates you will need to have to properly secure your application. Therefore, we have these viewers connected together, and we have these dashboards available, like constraints or policy gatekeeper manager who has its own, let's say, UI, and we connected it under one umbrella. Now it's here, and you can see all these let's say, constraint templates and constraints which are available. Then in monitoring, which is the second one, you can see different dashboards from the Kubernetes perspective. Like 1K8 is one of the famous, let's say, dashboard, which brings a lot of information inside how the cluster works internally. And then, of course, the metrics from the Cilium perspective, how the things works on the network layer, what packets, what is the performance, how the nodes connected together. So simply just to view what is the dashboard, what we can get at this moment from the testing server, or what are the Cilium metrics, so we can get very deeply inside what is in the cluster. And then Hubble brings the overall view on different levels, and then of course we can set different network policies, like for the egress, ingress, which pods can connect to which pods in the namespace, etc. So it brings or helps creates the opportunity to fine-tune the security on the application level as well. So I'm touching the final slide from my presentation, and this is that we have already interactions with different use cases, which we call it like UC1, UC5. We are in discussions and cooperation. I must say that it is surprisingly working, that the teams are quite experienced, and they can accommodate the pipeline and secure the build of the image, secure it, and then store it in Harbor. And what you can see already, that there is a shared repository for different use cases, and the users are, or the use cases are having the different namespaces available on the production cluster. So, okay, so thank you very much. I'm touching the summary. So development, secure supply chain practice for us is following the DevOps catalog, prepare for your build, securing the platform on the runtime, and giving you secure viewer from a different perspective. So thank you very much, and I'm opening now to the questions. Of course, here is the contact. If you need some additional information, you can touch us or contact me directly. Thank you.
Thank you very much, Mikulas. Let me put here the slide with the Slido document so we can have more questions, but we already have a few questions that arise during your presentation. So the first one says, how much time does it add to the step of signing the image? As in active development, any other time can really slow down the process of testing the features.
Yes. So the question is regarding how much time. Of course, depends how you build your application. Basically, if you follow the GitOps principles or maybe Git principles that you or DevOps that you build the image through the pipeline. So this one step is just to add additional component into your pipeline, configure the environment variables, read a little bit of the documentation which we provided to different steps, and tie it together. So what is our experience from the use case colleagues is that they follow this pretty quickly, and we were surprised from the week to week. I cannot tell you, let's say how much hours or etc. So let's put it in this way that this step to sign images instant. Yes, of course you need to set up the environment variables and do some connectivity check, etc. This may be some, let's say, time consuming, maybe one hour just to test everything works. And then, of course, you need to have the registry repository projects available, and you are good to go. So let's say it might be, I would not say minutes, maybe some hours. Let's say, thank you.
Okay, I think that you have already answered other questions that talk about guidelines to follow concerning image signing, because I think that you already answered to this and it's in your presentation. Yes. And the last question that we have is, beyond container image signing, how do you verify the integrity of dependencies through the build process?
Through the build process, there is of course the conf test. This is one thing which we also created. With the conf test, you can check the setup and integrity environment variables or everything which you are setting for your images, for your build process. And of course, what is also available, there is a sonar which brings you some additional tooling where you can see how your code behaves and do some analysis or quality gates for your artifact or for your image.
Okay, so thank you very much. The last question, I think that I can address it because it says that will the presentations be available to watch once the live stream ends and the demo videos? And the answer is yes and yes. We are going to send you also we are going to upload the presentations of the speakers to the Indico webpage. So if you register, you are going to get the link with these slides, and the video will be stored in the Siesta channel, and also the videos that the different speakers presented with the demos will be also published by the end of the day in the same channel. So that's all for today, for our third webinar. I want to again say thank you to Andrés, Saul, and Mikulas for their presentations, and I want to thank you all for attending this webinar and for joining us today to talk about the Siesta platform and the infrastructure. So thank you very much, and see you soon in our next webinars.
Thank you. Bye.
Bye-bye. Thank you.
Thank you.